You still have to identify zeros of polynomials when suitable factorizations are available. I'm giving it to you. And use the zeros to construct a rough graph of the function defined by the polynomial. And also graph linear and quadratic functions and show intercepts, maximum, and minimum. Here are the homework answers. Notice how it takes up most of the graph. We do not want to use a whole sheet of graph paper and do this. We are zooming in on the graph. That's the whole purpose of messing with the X and Y axes. Notice that every 2 blocks here accounts for 1. So in problem number 1, if you have this for the vertex, these for the X-intercepts, and this for the Y-intercept, and you've taken up most of the graph paper, then you're on the right track. On this one, we have an X-intercept here and here with a Y-intercept here, and this is the vertex. X-intercepts here, here, Y-intercept there, and a vertex here. X-intercepts here and here, Y-intercept there, and a vertex here. Here's an example. The problem is this. Quantity of x plus 1, close the quantity, times the quantity of x plus 8. Close the quantity equal to 0. Your first move is to find the x-intercepts. The x-intercepts are found by setting each expression equal to 0 and solving for x. So x will equal -1 and x will equal -8. Express those points as points. So that should be -1, 0 and -8, 0. The next thing you need to do is find the y-intercept. The y-intercept is essentially plugging in a 0 for x and then evaluating. 1 times 8. That is 8. Write it as a point. You're on the y-axis. That means you did not go left or right any amount, so the x value is 0. You're going up 8, so the y value is 8. 0, 8 is the y-intercept. Coming up next is the vertex. And step 1 to finding the vertex to find the x value of the vertex, which is the axis of symmetry. It's the line that cuts the graph in half. To do that, you use the x-intercepts that you found. You had -1 and -8. Add those together and divide by 2. -9 divided by 2 is a -4.5. X equals -4.5. X equals -4.5 is a vertical line up and down. Through the center of the graph you will draw. That's the axis of symmetry. To find the vertex as a point, you have to find the y value. And to find the y value, you have to plug in the x value, which is -4.5 plus 1, and then -4.5 plus 8. And evaluate that simple expression. -4.5 plus 1 is -3.5. -4.5 plus 8 is going to be a positive 3.5. You multiply those two together and come up with a -12.25. So combine this x value with this y value and come up with the vertex, -4.5, -12.25. It is an XY point. We are not using this piece of graph paper. You must create your own x-axis and y-axis such that you zoom in on the graph for the important points. So we will input that piece of graph paper. Here it is. We have to come over here to our work and determine what the x-axis is going to look like. First, you have to know what x values are and y values are. That's an x value. That's an x value. Y value, y value. X, y. X, y. X, y. What is the highest y value on this page? Eight. The y-intercept is 8. So our graph over here, we'll just do this. We have to go up to at least an 8 on the y-axis. What is the lowest y value on this page? Negative 12.25. So that's our y-axis. It has to go to at least 8 and down to at least negative 12.25. Look at the x values. What is the highest x value on here? What is it? I can't hear you. 0. Yep, it's going to be 0. So our highest is 0. What is the lowest? Negative 4.5. Are you sure? Negative 8. So it has to go from the left, negative 8, and then over to 0. Here's 0, here's negative 8. And actually this distance here should be longer than this distance there in reality. So we need to make that happen on our graph paper. We know the y-axis can be way over to the right. So that's what we're going to put in. Right over here. Let's just dump that in there. And we know that we have to be able to go up 8 and then down 12.25. So let's put in our x-axis. Move this over a little bit. Go back here. This is going to be the x-axis, and we have to have more on the bottom than we do on the top. So we should probably put it right about there. This is your x-axis. This is the y-axis. Include your arrows like this. And now we have to mark off the graph. In other words, we make the range. For our x-axis, we have to go from 0 on the right over to negative 8 on the left. Let's try to do that by 2 and see if it will fit in there. There's 1, 2, 3, 4, 5, 6, 7, and then 8. That is a negative 8. Negative 1, negative 3, negative 5, and so on. Now for our y values, we have to go up 8 and down negative 12.25. So we're probably better off just leaving it the way it is. If we try to go by 2's going up with what we have now, it's just not going to work out. So let's plot the x-intercepts. The x-intercepts are negative 1 and negative 8. So here's a dot on negative 1, a dot on negative 8. Next up is our y value. Our y, or our y-intercept is 0, 8, so put a dot on 8. Okay, so we go 1, 2, 3, 4, 5, 6, 7, 8. Make a dot. Next up is the vertex, negative 4.5, negative 12.25. Negative 4.5. This is a negative 4. So this is negative 4.5. Let's put an axis of symmetry in there. And we'll do that in red. Here's the axis of symmetry. The graph must be the same on the right as it is on the left of this line. The vertex is negative 4.5 and then down 12.25. So let's zoom in on this and count this out. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 0.25. Right about there. I'm going to need a thicker marker, so I will use probably this. And I'll do it in black. You have to have a curve like this. And it expands outward like that. Same thing over here. Same thing on both sides. That is a smooth, even graph. The X-Intercepts, we're going to do this first with a smaller pen. There we go. X-Intercepts, we need to do x minus 2 equals 0, x minus 3 equals 0. So x will equal 2, x will equal 3. And the points are 2, 0, and 3, 0. For your y-intercept, if you plug in zeros for the x's, you'll come up with negative 2 times negative 3, which is a 6. If you write that as a point, it will be 0, 6. And then for the vertex, your first move is going to be using the x-intercepts of 2 and 3. So 2 plus 3, and then cut it in half. That's 5 over 2, which is 2.5. That's the x value. To get the y value, you have to plug that back in. 2.5 minus 2, 2.5. I didn't mean to put that parenthesis in there. We'll just have to ignore it. Minus 3. That looks strange. And then we evaluate that. 2.5 minus 2 is 0.5. And 2.5 minus 3 is negative 0.5. Multiply that out and come up with negative 0.25. Your vertex is written as 2.5 and negative 0.25. Now we have to determine the x-axis and the y-axis. For the x numbers, our highest appears to be 3. We want to leave some room on either side because our graph expands, so we'll just make it 5. So if we go with 5, and what's our lowest x number? Is it 0? Do we have any x values that are negative? No. So we'll just go from 0 to 5, and then for our y-axis, we have a 6 in there. Is there anything higher than 6 for the y? What's the lowest for the y? Negative 0.025. Okay, so we're going to go from 0 to 5 on the x. We'll come over here and make note of that. 0 to 5 on the x, and then for the y, looks like we have to go up to 6 and down to negative 0.25. Okay, so our x-axis is going to be low. didn't mean to put that in there. I'm just hitting all kinds of stuff. We'll wipe that out. And our x-axis should be in here somewhere close to there, but we're going to move it down to about like that. And then our y-axis, since we're going from 0 to 5 on the x, shouldn't be too far away. My graph is tilted just a little bit. Alright, we'll go there, try to line it up as best as we can. We'll do that. So we have a y-axis, x-axis, arrows on both. Okay, but now our range, we're going from negative 0.25 up to 6. I think we might be able to skip, gosh, at least 3 on these, I think, going on the y-axis. So we'll go 1, 2, 3, 4, 5, 6. Could we have gone 4? Yeah, we still have plenty of room. So we can go back and do this. We'll use the red as the real hash mark. There's 1, 2, 3, 4, 5, 6. There's 4 and so on. And this is 1, 2, and 3. Alright, and for the x, we're going from 0 over to 5. We should be able to skip 3 on that. We might be able to do 4. I'm going to try 4. 1, 2, 3. I should have skipped one more. So I'll go with my white and take that out, and then go back to red. There's 3, 4, and then 5. Okay, so we have X-intercepts of 2, 3. We'll come in here and put a dot on the 2, a dot on the 3, and our y-intercept is 6. So come up here and put a dot on the 6. Our vertex is 2.5 and negative 0.25. Well, here is 2.5, and I'm going to put an axis of symmetry in there. I'll make it red. There's the axis of symmetry, and we have to go down 0.25. Now remember, we used 4 marks on the y-axis, and if I'm looking at this right, I think my 6 should be up one more, up to there. So I'll just make my dot go up to the 6 on that, and then we'll go here and just wipe that out with some white. Alright, we have to go down 0.25. If we're using 4 blocks as 1, here's the 4th one. That's negative 1, so it's already cut up for us. So this would be negative 0.25. Nothing left to do except draw the graph. Okay, we'll come in here and use black. It's got a curve like this. We'll go there. And it can't, you really shouldn't go any further since the other side doesn't go any further up, so that's the best we can do to zoom it in.